Hello students, welcome to these video sessions, and we are in a just starting of the class 12th chapters, and the topic that from last few videos is coming, that is electrostatic potential. Fine. So today this is your second chapter basically. So you are just in the class 12th initial stages. So today we are going to discuss electrostatic potential associated with electric dipole. Fine. So let me first mention the topic of today's class, that is potential, obviously electrostatic potential due to dipole. Simple. Fine. Now, if you try to recall that during the discussion of electric field, we explained you the concept of electrostatic, this electric field associated with the electric dipole, and today we are going to discuss electrostatic potential associated with the electric dipole. The basic difference is what? The basic difference is field is a vector quantity, and there I discussed first a complicated general approach. Then I said if theta is equal to 90 or theta is equal to 0, then what should be the situation? But potential is a scalar quantity, first thing. So I have two options to start. Either I should start from a difficult approach, then I will go for the simple approach, or I should start from a simple approach, then gradually move for the difficult approach. So I am going to opt other way around. First I will explain you difficult approach. Reason being, this difficult approach will give you a general result, and in this general result, by putting various values, as I will explain you, to get simple results. But in examination, if specifically a case has been asked, don't derive this general complicated results, because school teachers are very specific about the questions. So if it is mentioned find the electric dipole associated, find the electrostatic potential associated with an electric dipole, let us say for a point perpendicular to the dipole, then you have to draw the complete diagram, show all these components like charges, distance, this electric dipole, its direction and what not, and then write down. Fine. Here I am going to start general approach. Fine. General approach. Okay. So what exactly the general approach? First I am going to draw a good big diagram at this place. Then I will use this space to mention important terms. Fine. So that the diagram is present in front of you, and whatever I am explaining, that is also present in front of you. So I will try to use various colors to explain the situation. So situation is like this. This is arrangement of electric dipole. Fine. I think I should use very colorful diagram for all of you. So let us say this is red color, means positive, and this is going to be negative charge. Let us say this is point A, this is point B. Let us say distance between AB is 2A. 2A. Fine. Now the direction of the dipole is going to be in this way. This blue color arrow, I am showing the direction of electric dipole movement, that is P. Fine. So this is the direction of P, minus to plus. Now assume a point P over here. This is point P and this is vector P. Point P is point where you want to find the potential, and this vector P is what? electric dipole moment, that is 2A into Q. This is plus Q, let us say plus Q, this is minus Q. Fine. Now attach this point with the point B. Simple approach. Then let us say this is point O. O means center of dipole. Draw a straight line like this. Fine. Let us say this is R. OP is R. Fine. Now add point P with point A like this. Fine. Now you have to do something extra over here. Draw a normal from here to this point, means this angle is 90. Okay. Similarly, draw a normal from this point over here, that is this way 90. And there are two angles which are clearly visible to me, and these angles are, I think I should use red color. One is this angle theta, another is this angle theta. Fine. So now let us say name of this point is D. Okay, DB. And let us say name of this point is C, AC, okay, OP, PB, PA. Just take a look of the diagram for few seconds, close your eyes. Again, open the eyes, take a look, close your eyes. This is the way of capturing a snap in the hard disk of your mind. Find permanent memory. After that, you will not forget this type of arrangement. Now, I would like to mention few points over here, that is OC, that is this distance. OC is equal to OD. OC is equal to OD. Please take a look, is nothing but equal to 2A cos of theta. Fine. That is going to be 2, no, not 2, because 2A is complete distance. So it should be A cos theta. Yes, A cos theta. From here, just take a look. Fine. Now, V is potential at P. Let us say V is the potential. Let us say, let V is potential at P, at point P, obviously due to this dipole. So if V is the potential at this point P, then what I can write down? I can write down V is equal to K. K means 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So not R square, V is equal to K. K is 1 upon 4 pi epsilon naught, simple, this constant term. So K is this K, then Q upon PB. Take a look of this term, minus Q upon PA. I hope till now you all are comfortable. Fine. Now we will try to find the value of PA and PV. How we will find the value of PA and PV? So let me allow to write down, I mean to cut this portion and place over here. Why? Because I want to write down something over here in which I will use this diagram again and again. So I want this entire space to be free. So because now this term is clear, so it's going to be B, this is going to be Q, and V is equal to K, Q upon PV minus Q upon PA. Fine, let's erase it out. Now first thing that you have to find out, you have to find the value of PA and this PV. Fine. So from the diagram one thing is crystal clear, that if, also I am using this condition while it is not required, but anyway, if R is very greater than this A, that is OP is R, and if the value of R, it means what? It means the point at which we want to find the net potential is situated far away from the center of the dipole. So that's why I mentioned if R is very greater than A. Fine. Then PA, and this is very simple basic algebra, and which is, if you are unable to apply that, simply I am mentioning the terms, you just have to learn these terms. Fine, just two terms required. So PA is equal to R plus A cos theta. No problem. Fine. Similarly, I am not devoting much time on this trivial algebra part, because these values I should try to use directly. Now PB is equal to, now if this term you are able to write down, then just by applying basic logic you can say R minus A cos theta. If you are not interested to calculate all these using basic things, simply write down this is equal to like this. Now what you will have to do, you have to put this value and this value in this particular expression. So let me write down. This is equation number 1, this is equation number 2, and let's say this is blue box expression. Fine. So by, I am trying to write down each and everything close to this diagram, because lot of things associated with this diagram. By putting values from 1 to in this box. Fine, I hope now clear. So how exactly you can put the values? Just let me allow to write down over here. Obviously then you can say V is equal to K, fine, Q upon, what is this? PB, PB is this much, R minus A cos theta, and then minus Q upon R plus A cos theta, R plus A cos of theta. Fine. Why I am writing these terms? I can do directly, but thing is that it will inculcate a bad habit in your approach, and in school exams if you are not putting things like this in your answer script, your very accurate school teachers, accurate in the sense they love to follow small steps. For mentors like us who are supporting you to prepare for your IITJEE exams, we want correct approach, we don't. Here it's your first question. The capacity of an earthed spherical conductor is how much? It's a very tricky question. No formula, nothing. Very simple and tricky. Tricky in the sense, there is one specific term mentioned over here, that is earthed. And the symbol of earthing in any type of circuit is like this way. Let's say for example, this is a capacitor, say for example, and earthing means the symbol is like this. Fine. And as you know, earth is a infinite reservoir. You may take out infinite amount of charge and you can provide infinite amount of charge to the earth. Okay. So earthed spherical conductor. Fine. So what we will do, we will first try to draw this simple diagram. Let us say in general the conductor is spherical in nature. Okay. And wherever it is connected, let it be like that, but earthing is given in this fashion. Fine. So this is now earthed spherical conductor. So what about its capacity? Capacity means capacitance. C means ability to retain charge. What is the basic formula that we are supposed to use? That is Q is equal to CV. Fine. So from here what we can say, C is equal to Q by V. Okay. Now we will try to find out how exactly you are going to get the value of this capacitance. Now you can provide any amount of charge to this conductor, not a problem, but because of this earthing phenomena, what will happen? This V is going to be 0, and if V is going to be 0, then something upon 0 is you know what. So let me give you the simple solution of this particular problem. In any condition V is equal to 0. So therefore C is equal to Q upon 0, and that will give you C is equal to infinity. So the correct answer is this one. Just because of the earthing, whatever is the charge, basically potential is 0. That is the simple logic behind this question. Now in JEE Mains and JEE Advanced exam, these type of questions are very common. Common in the sense 1, 2, 3, I mean like nearly 1 or 2 questions till 3 number of questions. You may get these type of questions from different topics. They are very simple, and I should use the word crispy questions. If you are slightly confused, then you are going to get the wrong answer. So that's why I am starting this entire discussion with the help of this very first question, just to give you the different feeling or approach. Fine. As such, this is not difficult, but at least basic conceptual clarity must be in your mind, and that is what is the method of earthing, what are the aspects of earthing, why earthing is necessary. So all these things are quite essential. Fine. Then comes this question. The capacitance of a spherical conductor depends upon what? These are certain options given to you. So what I will do, let me allow to draw a simple diagram over here. Fine. And then one by one I will explain you what exactly has been asked in the question and what is the correct solution. So for the time being, if some portions are not visible to you, don't worry. It is like that, this is a conductor. Fine. So problem is, at what parameters this capacitance depends, this capacity of this conductor depends. Okay. So Q is equal to CV is a correct formula. Fine. And C is equal to Q by V. Just 2 minutes back we completed this discussion. Okay. Now we have to find out at what values, I mean these parameters, C depends. So first hand you can say charge and potential on both capacitance depends. Remaining I will let you know. So first is electric charge stored on the conductor only. Fine. So capacitance depends upon electric charge only? No, it depends on voltage also. So this first option, it don't seems it's a correct option. Okay. Electric charge stored and potential through which it is raised. Fine. Now this may create some sort of confusion. Electric charge and potential, both terms are clear. So is it like that? Wait. Fine. This put in you can say suspect, in the category of suspect. Correct answer. Fine. Then is shape, size of conductor and medium in which it is placed. Okay, shape, size and medium also, it seems, it may be. Fine. Only shape of the conductor, no. So A and D outrightly rejected. This is basically the method that you should follow in examination hall. Why? Because this is known as the intelligent elimination. So now in next reading you need not to read option number A and option number D. So now you have only two options. So this is something which is known as elimination process. Fine. So now we will try to focus our attention only on for B and C. So let me allow to write down over here. V is equal to 1 upon 4 pi epsilon naught Q upon R. Why I delayed the presentation of these questions based upon capacitance and this electrostatic potential? Reason is simple. After completing all those chapters, now if I am anything writing, you may easily understand what I am writing. So that is the main point of delayed presentation of these questions. Fine, I not presented this question just after finishing the chapter. So this is potential 1 upon 4 pi epsilon naught Q upon R, a well known formula. Okay. So from here, as C is equal to Q by V. Fine. So place the value of B from equation number 1 in equation number 2. Okay. So therefore C is equal to Q, this Q upon Q into 4 pi epsilon naught R. I hope you all are comfortable with this expression. One thing that you can add more over here, that is, this is epsilon naught, permittivity of free space, and one more term, that is epsilon R, permittivity of medium, relative permittivity, that is known as. So now this Q and Q going to be cancelled. So C not depends upon Q and V only, but C depends upon size and shape of the conductor and relative permittivity, or you can say in simple terms, on the medium. Fine. So now if you talk about electric charge stored and potential through which it is raised, then it is not like that C depends only upon Q and V, but C also depends upon radius, means the size, also depends upon relative permittivity. Fine. So that's why option B is not correct one. Shape, size and medium in which it is placed. So this one is the correct answer. Fine. C is the correct answer. And these questions in capacitance and this potential, it's a very important topic, very good topic also. Fine. Initially I am discussing very simple questions so that you can start a liking in your mind about the numericals in physics, because general complaint of the students is what? Physics is simple, we can understand, but we can't solve the problems. Numericals, oh my god, that's very difficult. So that's why I am starting the discussion with the very simple questions. A 40 microfarad capacitor in a defibrillator is charged to 3000 volt. The energy stored in the capacitor is sent through the patient during a pulse of duration 2 milliseconds. The power delivered to the patient is how much? Now what exactly this question is? One, this defibrillator, then patient, and then what exactly? Let me explain you. as you know students, in medical science maximum instruments are made using the concepts in physics, whether it is X-ray, whether it is MRI, CT scan and so on and so forth. Fine. So now this device defibrillator, it is used to you can say provide some sort of shocks to the heart so that it starts pulsing, these pulses. Fine, pulses should start come out from that natural pump which is responsible for pumping blood in our entire body. So now this is a device, and this device works on the principle of energy stored in the capacitors, and then as and when required it utilizes that. So you have to find out the power delivered to the patient in 2 milliseconds. Fine. How exactly we can find out? If you have regularly watching these videos of theory, then very easily you can understand one thing, which is something I mentioned over here, that energy stored in a capacitor is half CV square, this type of relation. Fine. So let me allow to write down few terms over here. At least I can write down U is equal to 180 Joule. Many of you may think from where we are getting this formula. So simple, we are getting this formula from the relation, that is I am going to write down over here, it is half CV square, or I think I should write it over here only with different color chalk, that is U is equal to half CV square. Values are given, fine, C given, V given, you just put the values and this number is your first outcome. Then what exactly this outcome is going to be used? So U is equal to 180 Joule, and what is required? Power. Power delivered to the patient. Now the question is simple, fine, it is not like that very difficult question, simple question. Let us try to understand. You have two identical capacitors, fine, and they have same capacitance C, okay, as such this line is itself self-explanatory. One of them is charged to potential V1 and other to potential V2. So initially the charge was 0 on the capacitors. Now two equal capacitors, equal means same capacity, they are connected to potential source. One is charged with the potential V1, another is V2. Accordingly both have some sort of charge development, charge accumulation. Obviously it is going to be different. Now likely charge plates are then connected. What is the meaning of this? Let me explain you. Let us say this is one capacitor, just a symbolic representation, and this is another capacitor. So likely charge plate means, let us say this plate is positively charged, this one is positively charged, and let us say this one is positively charged separately. So connect positive charges, fine, positive charge plates, that is the meaning of this line, that like charges plates are connected. Then what is the decrease in energy of the combined system? That you have to find out. Now till this line V2, question is simple. Like charges plates are then connected, okay, it is a process. After that I think few of you who are not regularly in touch with the concepts, means they are not revising, they will find some sort of difficulty with this line, which is the basic theme of this question. First question can come in your mind, why decrement in energy will take place when you connect same charges, like charges plates together? What exactly the cause? This question definitely will come in the minds of many students watching this video. My point is, please try to revise yourself, because if I will explain the meaning of this line, then obviously you will not put focus onto your basic approach of revision. So please revise that. Why it is that energy is decreasing, why it is not increasing, what exactly the cause, please at least work upon these small points. That way you may enhance your understanding of this topic. What I'll do, I'll definitely going to be focus only on to the explanation of this solution. So because as such no space is available over here, so what I will do, I'll use this space to explain you. Now decrease in energy of the combined system. So it is something that if you can find out initial energy and final energy, so difference of initial and final, you can simply say this is the decrease in energy. Okay, so let me allow to write it down in this fashion. Let delta U is decrease in energy. Now delta U is nothing but U initial minus U final. Again few of you may think, why initial energy more, why final energy is less? Fine. Now one by one I will write down the expression for initial and final energy, only then I will provide you the exact solution. So from here, if I am using a different color chalk and I am saying U initial is equal to half C, because capacitance is same, half C within bracket, this is going to be what? V1 square plus V2 square, half C V square is the general result. So it is V1 square plus V2 square. This is the initial energy of the system, I mean the initial energy of both the capacitors. Okay, let us say equation number 1. Fine. Now final energy U final is equal to half into 2C. Answer of my question hidden in this bracket, and that is why I am specifically mentioning it. Fine. What is the meaning of connecting positive charge plates or negative charge plates? That is hidden over here. So half into 2C, and then when you connect it, potential will be bifurcated, changed. So that you can mention using this way, that is V1 plus V2 by 2 whole square. Fine. This is equation number, let us say 2. Now ultimately nothing is so difficult left as such over here, just put these value, solve it, you will get the answer. What I will do, I will write down next step at least for your understanding. So please, delta U is equal to this 2 and 2 gets cancelled, here it is 1 by 2 C, then this bracket minus C, then this bracket. Fine. So let me allow to write down that C by 2 V1 square plus V2 square minus C V1 plus V2 upon 2 whole square. Okay. And from here I think solving it a very simple process. So I hope everyone can do that. What I will mention over here, that after solving this equation number, let us say 3, after solving this equation number 3, what will happen, that C is your answer, that is 1 by 4 C V1 minus V2 whole square. So let me allow to mention, after solving equation 3, C is correct option, this one is the correct option. Fine. So I am only not solving just this last equation where you just have to take common terms one way out, and then you can arrange the various remaining term over there. So, this was question number 6 which we attempted just right now. What exactly the idea of the question and what exactly the correct answer. Still my question is there, why the energy is decreasing when you are connecting together like charges plates. Fine, please try to find out the solution or answer of this problem. Then comes this question, the magnitude of electric field in the annular region of a charged cylindrical capacitor. Now, this cylindrical word is underlined. Why? Actually, in your NCERT book, only parallel plate capacitor is defined as such. Spherical, cylindrical, all these type of capacitors are not specifically mentioned for your course. But if you are preparing for any competitive exam, then you cannot be selective like I will not prepare that. If some correlated topics are there, and this is a natural you can say question that can come in your mind. Whenever you start discussing capacitors, a natural question can come in your mind, is it like that capacitors are only parallel plate? No, because if you examine actual circuits, TV or your laptop or your computer like that, mobile even, you will find even your ceiling fan, fine, which is one present in this studio also, they have capacitors and the size shape of the capacitors is different. So, obviously, when you want to study some topic, you want to study it in up to some extent in totality. So, I thought just for a change, because parallel plate capacitor every time you will at least you can think in your mind, is it like that? And say for example, one electrician is opening a ceiling fan that is attached in your school or in your home, and then you will just for the curiosity taking the look of the capacitor and it is cylindrical or other way not as exactly as parallel plate, then you may think is it like that I am studying only half of the topic. So, I thought just put this question over here. Now, magnitude of electric field in the annular region of charged cylindrical capacitor. What is the meaning of annular region? It is like that it is outer cylinder and in this outer cylinder this blue color is inner cylinder, dotted because it is from inside. Okay. So, annular region means this entire region. Okay. I will not make this explanation very difficult. Directly I will use Gauss's law for finding the electric field. Now, see the beauty of the concepts over here. You are studying a topic in this chapter and you are using that topic for various chapters. So, in physics the most beautiful part is it is a correlation of various topics. Study one topic and you will find yourself in a comfortable position in another topic. So, now from here what using Gauss law, I will mention it just so that you can feel it from where you are getting it. Using Gauss's law, fine. E is equal to 1 upon 2 pi into lambda upon epsilon naught r. R is the radius of this zone. So, what is the direct result you are getting? E is directly proportional to 1 upon r. And if I am asking you what is the name of lambda, you will without even a second waiting will say line charge density. Fine, because three type of charge densities we discussed: line charge, surface charge, volume charge. Fine. So, lambda is line charge density. Okay, lambda is line charge density. Now let's start analyzing the options using this relation. Fine. If any one of you is interested to achieve this result, my best wishes are with you. Start using Gauss law. You can do that, you should do that. Fine. That way you are learning this device or not, that is not important. Important is you will learn an application of this Gauss law. Okay. So from here what the relation we have, E is directly proportional to 1 upon R. So now let us start. Electric field is same throughout? No. B is higher near the outer cylinder than near the inner cylinder? No. Varies as 1 upon R, where R is the distance from the axis. So what I mentioned, this is your axis and this distance